Hello students, welcome back to my YouTube channel. This is Kasha Masoni and today we are going to start another topic in this chapter, carboxylic acid derivatives, which includes the chemical properties of esters. So far we have discussed about your acid chlorides, your acid anhydrides, and we have taken the general introduction of your esters till physical properties. Okay, and today we will be discussing the chemical property, the first chemical property of the same, that includes the hydrolysis reactions. Okay, so if you have not seen any of the videos that I've uploaded in this particular series of carboxylic acid derivatives, I request you to check the description box. I'll mention the link over there. Just check this first and then switch to this particular part of the chapter. Okay, so without wasting any more time, let's just switch to the chemical properties of esters. Alright, so basically we are going to see all the nucleophilic acyl substitution reactions, which will be including hydrolysis, alcoholysis and ammonolysis. First we'll be talking about hydrolysis reaction. So what is exactly happening in this case, that your esters are actually slowly hydrolyzed while when we are talking about neutral medium. Okay, in neutral medium your esters are slowly hydrolyzed as compared to your acidic and alkaline solution where they are rapidly hydrolyzed. Okay, whereas in acidic hydrolysis it will be yielding carboxylic acid and alcohol. The alkaline hydrolysis gives alcohol and salt of carboxylic acid. That is another thing कि जब आप acidic hydrolysis करेंगे आपको जो product मिलेगा वो होगा आपका carboxylic acid और alcohol. वहीं पे जब हम alkaline हाइड्रोलिसिस करेंगे तब आपके पास जो प्रोडक्ट ऑब्टेन होगा दैट वुड बी योर अल्कोहल एंड सॉल्ट ऑफ कार्बोक्सिलिक एसिड. सो बेसिकली आप यहाँ पे क्या देखने वाले हैं, योर एसिडिक एज वेल एज बेसिक हाइड्रोलिसिस. करेक्ट. So what is happening exactly? As I told you, they are slowly hydrolyzed in neutral medium and rapid in acidic and alkaline solution. So over here you can see the reaction of an ester with water, that is your neutral medium, and it leads to the formation of carboxylic acid and alcohol only. Okay, that is one thing. So this is your first hydrolysis and that is occurring not in your neutral medium, actually it is occurring in your acidic medium. Okay, and H positive came from your mineral acid like H2SO4 or HCl. It could be anything. Okay, then next one is your where your carboxylate ester is reacting with sodium hydroxide, that is a base, and this result in the formation of your sodium salt of carboxylic acid and an alcohol. So this is your alkaline hydrolysis and you can give it a name as saponification. So this process is actually also known as saponification. So if your examiner asks you in the subjective paper about saponification reaction, you can write this particular reaction and explain it as well. Okay, so proceeding further to the basic difference between these two. See, your acidic hydrolysis is actually reversible while your alkaline is irreversible reaction. That is one thing about it. Why this is the case over here? Because it is due to the fact that your carboxylate anion formed in this particular alkaline hydrolysis, that is actually better stabilized over here. If you talk about alkaline hydrolysis, over here your carboxylate anion formed is better stabilized by resonance, while this is not the same case happening over here in acidic hydrolysis. Okay, so next over here we have the mechanism of alkaline hydrolysis. So let's just take up the mechanism first over here and let me change the color of the pen. Okay, so this is your carboxylate ester. You can see this one is your carboxylate ester, and what is now exactly happening? This will be OH negative, that is your hydroxide ion will be acting as a nucleophile over here. Okay, what is happening exactly? The oxygen, being electronegative in nature, will be attracting the shared pair of electrons from this pi bond towards itself, making this carbon susceptible to get attacked by your hydroxide ion. Okay, that is one thing. कि क्या हो रहा है, ये जो आपके ऑक्सीजन है, it is more electronegative in nature, तो क्या करेगा? It will attract the shared pair of electron towards itself, making this particular carbon electrophilic or susceptible to get attacked by this nucleophile. Understanding? So that is one thing, and it leads to the formation of this particular tetrahedral intermediate that you can see over here. Okay, so now what is happening in this step? Now the lone pair of electrons from your oxygen is back transferred to this particular sigma bond between carbon and oxygen, and this one oxygen will be accepting pair of electron from this sigma bond, and now what is happening? Your alkoxide ion will get released from here, making their giving your carboxylic acid as such. And after this reaction, what will be occurring, the third step would be your proton exchange, which will lead to the formation of your carboxylate anion and alcohol. So that is the mechanism of your general mechanism of your alkaline hydrolysis, basically a two-step mechanism, and this is also similar to that of your SN2 reaction, that is your bimolecular nucleophilic substitution reaction. Okay, so that is another thing. And over here they have just mentioned the steps that I have mentioned in the previous slide, in this particular slide. So all these steps are written over here. Okay, if you want me to explain it again, then here it is. See, in the first step, what is happening? There is occurring the nucleophilic attack of your hydroxide ion. I told you it will be acting as a nucleophile on the ester carbonyl, forming tetrahedral intermediate 1. Now, what is this? Now, this particular reaction, in this particular reaction, this particular step is your rate determining step, or you can say it is a slow step. Okay, so this is your rate determining and slow step, correct? So that is one thing. Now this step is reversible and it constitutes rate determining, as I told you, the same thing. The tetrahedral intermediate then quickly displaces an alkoxide ion, ultimately giving a molecule of alcohol and carboxylate anion that I have already mentioned. Okay, so there are some evidences in the support of your alkaline hydrolysis, which include kinetic studies, then comes site cleavage, isotopic traces studies, stereochemical studies, and formation of tetrahedral intermediate. So let's take all of these evidences one by one. Talking about the very first evidence, that includes the kinetic studies. What is exactly happening? See, this mechanism shows the rate of reaction should depend upon the concentration of both your ester as well as hydroxide ion, which will be making it following your second order kinetics. Because why it is second order kinetics? Because rate of reaction is depending upon ester, the concentration of ester, as well as hydroxide ion, which is why it is your second order kinetic. It is following your second order kinetics. Correct? Now, second evidence is your site of cleavage. See, this mechanism involves the cleavage of bond between oxygen of OR dash group and the carbon of your acyl group, like this. This is the way of cleavage is occurring in this particular mechanism, and this type of cleavage is further confirmed by the another evidences that we are going to talk over here, that includes isotopic traces studies and stereochemical studies. So third evidence is your isotopic traces studies. Over here you can see the reaction that is occurring between ethyl propionate and your OH negative ion, which leads to the formation of your propionate anion and ethanol having, okay, this ethanol is having your oxygen having isotopic number 18. Okay. And that is what we are going to discuss over here. What is the reason behind the same? Let's see. Let me just get back to the previous slide first. See, what is exactly happening over here is when your ethyl propionate, like this particular substrate is reacting with your hydroxide ion. What is happening exactly in this ethyl propionate, in which your ethoxy group, that is this group, has been labeled with your O18 when it is hydrolyzed with alkali OH negative or either in ordinary water. What is happening? The ethanol produced, like this particular ethanol produced, is found to contain O18 over here, while the propionate anion formed is containing your ordinary oxygen, that is your O16. Okay. So what is happening? This particular propionate anion formed is found to be containing your oxygen, which is having isotopic number 16. Okay, like this. Okay, let me change it to pen first. Okay, like this, 16 over here. So this propionate anion is consisting of your O16, that is ordinary oxygen over here. So this is possible only when the cleavage is occurring like this, RCO O R dash. If cleavage is occurring like this, it is only possible then. Otherwise, if the case is the cleavage, if it is occurring between oxygen and ethyl part of ethoxy group, then this is not going to be the case. Okay, so this is how you have proved the your alkaline hydrolysis mechanism via isotopic tracer studies. Okay. Proceeding further to the another part that includes your stereochemical studies, this one. Okay, what is happening over here? Your oxygen cleavage is supported by alkaline hydrolysis of optically active esters. Okay, so the site of cleavage that we have discussed, that is further supported by another evidence, that is your stereochemical studies. Okay, see what is exactly happening over here. See, in the first reaction, if you have taken the example of the hydrolysis of optically active esters, which is derived from your benzoyl chloride. Okay, this the first one and second case you can see, we have been talking about the hydrolysis of an optically active ester which is derived from your benzoyl chloride. Okay, now just let me change the color again. Okay, see what is happening. In this particular case, if alkaline hydrolysis of this ester is involving the cleavage of bond between oxygen and secondary butyl group like this, if this is involving the cleavage of your oxygen and secondary butyl group, what would you expect? You will be expecting either the complete inversion of the configuration, okay, understanding it will be occurring, or either the complete inversion if hydrolysis occurs by SN2 mechanism. Okay, so what I said, if the cleavage is occurring between what of the which bond? This particular bond, oxygen and this of your benzoyl secondary butyl group, this particular benzoyl group and this secondary butyl group. If the cleavage is occurring like that, what is happening? Then we can expect the inversion of configuration like this. So this is how your product is going to be. Let me just completely write the product. It is going to be C2H5. Okay, so here cleavage is occurring between oxygen and one your alkyl group. Okay, and then you are going to get your inversion of configuration reaction. Okay, product. Okay, and if the case is otherwise like that, if hydrolysis occurs by SN2 mechanism or inversion with some racemization, that is the case with of your SN1 case. Okay, when you are getting the racemized product, that is going to be the case of your SN1 mechanism. Okay, if on the other hand, what is occurring, the bond between your oxygen and over here you can see the bond between oxygen and secondary your secondary butyl group, it will remain intact. This bond remain intact, and over here what is happening, the cleavage is occurring from here. So what is going to happen, you are going to get C6H5 C double bond O negative, and this is the alcohol, your secondary butyl alcohol, that is what you are going to get. But over here the configuration would be changed, and over here you are going to get the retention of configuration. So the case is otherwise. Okay, so over here also likewise you can say what is happening. Over here you can also mention that how exactly the cleavage is occurring. So the cleavage, like this cleavage, this particular cleavage is supported via your stereochemical studies, just like that. Okay, so that is another evidence. Just switching to the last evidence of this particular topic. Let me just get back to the previous slide. All right. Okay, so then we have the formation of your tetrahedral intermediate, that is includes your first pathway, where what is happening, the direct displacement of alkoxide ion is occurring. Okay, you can see the direct displacement of your alkoxide ion by hydroxide ion. Okay, like this. But actually in real cases it doesn't happen. However, this path actually doesn't go on like that. So we'll be checking out the another path, that is your second pathway, like this. What is happening over here, your attack of OH negative ion first occurring, okay, just let me get back to the previous slide. Yeah, so what is happening exactly, your attack of OH negative ion first occurs on carbonyl group to form tetrahedral intermediate, which then loses your alkoxide ion like that. So this one, your starting material is your labeled ester, which is now getting reacted with your this hydroxide ion, and it results into the formation of your tetra intermediate like this, and which will be giving you product like this. So this is just similar to the your first starting reaction that we have discussed. But what is happening exactly over here is your scientist, that is your Bender, he studied the hydrolysis of this ethyl benzoate in ordinary water, and then what he has actually observed is that he actually found that in alkaline solution, ester is not just undergoing hydrolysis but also exchange of your O18 for ordinary oxygen from the solvent. Okay, just like that as mentioned in this particular reaction that you can see by your own. So I'll stop the video over here only. Rest of the chemical properties we'll be taking up in the another videos that I'll be uploading most probably today only or tomorrow. So yeah, thanks for watching. Do like, subscribe and share my channel. Thank you.